In example 4, we're looking at what we call a contingency table. This is a table that has two sets of categories. So in example 4, we're dealing with an individual, which is either male, female, and then we're dealing with a pet. So here in this data set, we have dog, cat, or other. And whenever we have a contingency table, we can also use it to calculate probability. So let's look at example 4. Okay. A sample of 100 individuals who have one pet in their home. Okay, so that's displayed in the data set here. And we're going to look at each one to see how we calculate the following. What is the probability an individual selected has a dog or cat? And notice, what's the keyword here? The keyword is or, right? So here we're going to denote the event dog as D, the event cat as C, and we would like to find the probability of selecting an individual that has a dog or cat. And if you remember, the word or has two formulas. Okay, one, the formula is for disjoint. So for the disjoint, you have probability of A or B is equal to just the individual probability added together. But we also have, if you recall, let's do this. This is for disjoint. But we also have the probability of A or B is equal to probability of A plus probability of B minus the overlap, right? Minus the overlap. So we need to determine whether dog, cat, those two events have an overlap, okay? So going back to our example, okay, here it says a sample of 100 individuals who have one pet. So that's the important thing, only one pet, okay, in their home. So if I randomly select an individual, is it possible for that individual to have both dog and cat? Okay, since they can only have one, the answer is no. So dog, cat, there is no overlap between those two events, okay? So here we're dealing with disjoint, okay? So we're going to take the probability of dog plus the probability of cat. And the way we use this table, okay, so what we're going to do is we're going to look at the event dog, okay? And in the event dog, it doesn't matter whether the individual selected is male or female, okay? It doesn't matter if the person is male or female. We want to know how many dogs are in the data set. So here we have 40 plus 9. So we're going to say dog is 49 out of 100. Okay, so we have 100 in the data set. Plus, and then similar here with cat, we don't care if the person is male or female, the individual. All we want to know is how many cats are in the data set. So here, 10, 29, that's 39. Okay. So we add these probabilities together. Okay, that's going to be 88 out of 100. We can call that 0.88. Okay. Now let's look at part B. Okay, let's look at part B. It's very similar. What is the probability an individual selected is male or has a dog? So now we're looking for the probability that the individual selected is male or has a dog. Okay? And once again, the question is, do we have an overlap? Okay? Do we have an overlap, or are male and dog separate events that cannot happen or don't have an overlap? Okay? So here we took a sample once again of 100 who have exactly one pet. If I pick one person at random, is it possible that that person is male and has a dog? The answer is yes. There's an overlap between these two events. So we're going to use the formula for the overlap. So we have probability of male plus probability of dog minus the probability of the overlap. And I'll show you how to take care of the overlap here in a bit. Okay. So to proceed, we look at the male in the category here. And once again, it doesn't matter if the person has dog, cat, or other. All we want to know is how many male are in this sample. 40 plus 10, that's 50, plus 2. So we have 52 out of 100. Okay. Next, what we'll look at is the probability of dog. And once again, similar to the other, it doesn't really matter whether the dog owner is a person, male or female. All we want to know is how many dogs are in the study. So we have 40 plus 9, that's 49. Okay. But then what we're looking at here is the overlap male and dog. So what we need to do is we need to go to the data set here and look to see where does male and dog overlap. And notice that it overlaps right here, right? And how many do we have? Here we have 40 out of 100. Okay. So when we're looking to calculate this probability, okay, so we have 52 plus 49 in the numerator minus 40, that's going to be 61 out of 100, or we can call that 0.61. Okay, but notice how we did have an overlap this time. In the previous example, we didn't. It's important when we see that keyword or to ask ourselves, is there an overlap between the two events? Looking at part C. Okay. What is the probability an individual selected is female or has a cat? Very similar. So probability that the person is female or has a cat. Okay, once again, we see the keyword or. So the question is, there's two formulas for or. The question is there an overlap between the two events? So the study or the experiment, once again, has a sample of 100. These 100 individuals have one pet in their home. If we randomly choose one person at random, is it possible for that person to be female and have a cat? The answer is yes. So there is an overlap between the two events, female and cat. Okay. So here we can proceed like before, where we have the probability of female plus the probability of cat minus the overlap. And notice that we're using the contingency table to calculate the probability. Okay. So we'll look at the female. Here, it doesn't matter whether the person has dog, cat, or other. Okay, we just want to know how many females are in this study. Okay, so we have 29 with 10, that's 39. 39 plus 9, let's call that 48 out of 100. Okay. Plus, we want to know how many cats are in the study. Okay, it doesn't matter if the person is male or female. We just want to know how many cats, okay, are here. So 10 plus 29, that's 39 out of 100. And then minus the overlap. If you notice with the overlap female and cat, female cat, that occurs right here. Is that right? So here, the overlap, we're going to subtract 29 out of 100. Okay, and that'll give us our answer. This will be 58 out of 100, or 0.58.